equation for exponential growth. Now when we think about exponential growth, that means that something starts and it starts kind of small and it gets bigger and bigger and bigger. It grows exponentially. Okay, so yesterday when you did graphs, an example of an exponential growth graph would go something like that. Okay? So here's the equation. Y is the final amount. A is my initial amount. What's another word for initial? Starting. That is what you start with. Okay, that's what your initial amount is. Rate as a decimal. Okay, biggest thing is they're going to give it to you in terms of a percent. You need to make sure you answer that as a decimal. So if they gave you 5%, that would be 0.05. You always have to use a decimal on every one of these formulas. If they gave you, let's see how well you do at this one. I'm going to try and trick you. 2.5%. What would that be?
0.025.
0.025. Very good. Okay? T is your time. Your time might be in days, might be in hours, might be in years, might be in days. So.
You said days.
Oh, I said days, right? Okay. All right, so let's go ahead and look at this. It says the prize for a radio station begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5% for the next day. Write an equation to represent the amount of the gift card in dollars after T days with no winners. So let's go back to our main page. Our main page, Y equals A times 1 plus R to the T power. Y is the final amount of the gift card. We don't know what it is, so we're going to leave that as Y. What is my initial or starting amount? $100. Very good. Now I've got my parentheses. 1 plus, what is my rate as a decimal?
0.025.
0.025. And time, you don't know. So this is actually our formula. Now what I'm going to ask you to do is simplify things down a little bit. I'm going to ask you to simplify this parentheses. So that really what I get is I get Y equals 100 times 1.025 to the T power. Now, could you multiply the 100 and the 1.025?
No.
No, remember what I said. You have to do the power first and then multiply by the 100. You cannot multiply those two. So do not do that. Okay? How much will the gift card be worth if no one wins after 10 days? So how do you think I'm going to solve this?
Would pay 1.025 to the 10th power.
I'm going to put 10 in for T. Now we're going to go through this because you're going to need your calculator, okay? And there's a certain way that you're going to want to enter this in. Okay? And some of you have already been using the exponent key, and that's great, but some of you might not know where it's at. Okay? You're going to start with this right here. You're going to start with this. Now what you're going to do, depending on what calculator you have, okay? I see you've got some with the TI-30. If you have the TI-30 X2A, something like that, I think you have that one too back there, Ethan. You are looking for this key right here. Okay? What you're going to do to enter that in is you're going to take 1.025, you're going to hit the Y to the X key, and you're going to hit 10. Okay? Then what you'll do is you'll hit enter, and you'll take it times 100. Some of you others, you don't have a Y to the X key. You have one of these caret keys. It looks like a little hat. What you're going to do is you're going to take 1.025 caret 10. You're going to hit enter and then take that times 100. All right, does anybody else not have a caret or the Y to the X?
What do we take times what?
You take the 1.025 and then the caret key 10. You'll get an answer there and then take that times 100. What did you get when you calculate that?
128.00 or 01. 01 if you round up.
$128
And 1 cent.
and 1 cent. So after 10 days, it's went up 28 bucks. All right, questions? Okay, let's go ahead and look at another one. This is something that happens every year. They always talk about this. You always hear this in the news, especially when like the university raises its tuition. A college's tuition has risen 5% each year since 2000. If the tuition in 2000 was $10,850, write an equation for the amount of the tuition T years after 2000. Predict the cost of tuition for this college in 2015. First thing, we start with an equation. Remember our equation, y equals a times 1 plus r to the t. Do we know why? No, that's what we're trying to find. What is a?
10,850.
10,850. Then I go 1 plus, what's my rate? 0.05. What's my time? T. We don't know. Now remember, what we're going to do now is we're going to write this as a condensed answer. So I end up getting y equals 10,850 times 1.05 to the t power. That's your first answer. Now, notice what it wants you to do. Predict the cost of tuition for this college in 2015. So 2015, what would t equal? T equals 15 because notice what it says, years after 2000. So what you're going to do, I'm going to start with the 1.05 because remember we always do the power first. So 1.05 to the 15th power. When you get an answer for that, take it times 10,850.
Ooh.
Big number, what'd you get?
2,456.
20, what?
$56.37.
22,000?
Yeah.
Okay.
22 cents.
So in a matter of 15 years, the tuition has more than doubled. Does this happen a lot? You bet. Okay, just a little tidbit. When I went to Doane, the tuition was $5,500. Doane. Okay, now for those of you now, if you ever want to go see what tuition at Doane is now, yeah, like way, 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 way more. So anyway, that was kind of the tuition back then. So, yep, you can take them. So let's go ahead and look at this. Your equation for compound interest. Get it down. Write her down. Okay? Because this is where things get even more interesting too, because we're going to look at a lot of interest problems. Okay. Now, I don't know if you need to write A, P, R, and N, because I'm going to tell you what those are briefly. You don't need to put all those words. The biggest thing you need to get is that you have P parentheses 1 plus R over N to the NT. All right, so A is our current amount. That's the amount we want to find, just like Y was, real similar to Y. P stands for principal. That's always your starting amount. Once again, just like the problem before. So far we really haven't had anything different. R is your rate as a decimal. Already done that. The difference here is N. N is the number of times compounded per year. So example, okay, if I'm going to compound things quarterly, so if I'm going to compound things quarterly, as is like your savings accounts, that means how many times a year? 4. And think about it in terms of your grades. How many quarters do we have? We have first quarter, second quarter, third quarter, fourth quarter. So N in that case would be 4. Okay? If I wanted things compounded monthly, N would be 12. Good. Okay, let's throw another one at you. Semi-annually. 2. For those of you wondering how that works, a semicircle, there are 2 parts to a semicircle. So semi-annually means twice a year. Another one. Let's see how you do here.
355.
Okay, now there's some different schools of thought. In a lot of business books, they'll tell you to use 360 for daily. And it just depends on kind of what your book states, you know, because you have the leap years and things like that. When it says daily, we are always going to use 365. Okay, just going to keep things easy that way. Okay, T is our time in years. All right, so pretty much everything's the same as what we've looked at. We just got a little different. So it says Maria's parents invested $14,000 at 6% per year, compounded monthly. Okay, first of all, 6% per year is a fabulous rate. Okay, you aren't going to find that a lot now. Okay, compounded monthly. How much money will there be in the account after 10 years? So let's go ahead and write down our formula. So A equals principal times 1 plus R over N to the NT. So A is my final amount. That's what I'm trying to find. What's my principal? 14,000. Okay. What's my rate? 0.06. What's N?
10.
What's N?
12.
Thank you. The reason why it's 12 is it's compounded monthly. So we have 12 months in a year. And then notice it says N times T. What's T? 10. So notice you use the 12 twice. You always will do that. Now here's how you calculate this. Okay? You've got to simplify this first. Okay? So depending on what type of calculator you have, Lane, you're probably going to have to take 0.06 divided by 12 first and then add 1. If you have one of mine, you can type in 1 plus 0.06 divided by 12 and it'll give you an answer. Okay, it just depends on which one you have.
And then we just do plus 1.
Then do we have to take it to 40?
Just wait. Nope, nope. I want you to just tell me what it is as a decimal. What is that?
1.005.
0.005? Okay. So now my exponent here, what's 12 times 10? 120. So now this problem looks really familiar to the ones we just got done doing. What do we have to do first?
10 to the power.
Yep, you have to do this first. So the 14,000 is the absolute last thing you're going to do. So 1.005 caret 120. Take that times 14,000 and how much money does Maria now have?
$55,471.
55 cents. And what?
55 cents.
Okay, so not too bad. Okay, you're probably not going to get that money in a bank, that percent in a bank. This is going to have to be invested in some sort of mutual fund or something like that. Banks right now, especially like your savings accounts, my savings account when I was your age was getting 3%. Savings accounts now are like 0.5%. Okay, so that's really dropped. Alrighty, so now this is the equation for exponential decay. What I want you to do is I want you to look at the equation you wrote down at the very start of today's lesson and look at this one and tell me what's the difference. The minus sign, that's the only thing that's different. Okay, everything else is the same. So all you would have to do is write down this formula, just put exponential decay, write this formula down because you already know what y is. You already know what A, R, and T are. Okay. So exponential decay, all you're going to do is subtract the rate now. Yep. Okay, so let's go ahead and look at an example here. A fully inflated child's raft for a pool is losing 6.6% of its air every day. The raft originally contained 4,500 cubic inches of air. Write an equation to represent the loss of air. So y equals A times 1 minus r to the t power. Y is what we're trying to find, right? What is A?
4,500.
4,500. That is our starting amount. What is R? Oops, forgot the 1. What is R?
0.066.
0.066. What is T? T, that's right. So now, very first thing, what we're going to do is we're going to go ahead and rewrite this. So I've got 4,500. Now what I need to do is subtract. What is 1 minus 0.066? 0.934. 4. So there's your first equation. My next equation, estimate the amount of air in the raft after 7 days. So what are you going to do? You're going to plug in 7 for T. Very first thing you're going to focus on is you're going to focus on the power. What do you get when you focus, I forgot to put 7. Sorry. I'll erase that and get rid of that. There we go. 7 here. What do you get when you multiply that out?
6,200,270.
You got 0.62. Did you take it times the 4,500?
Oh, I did. Okay. 2,790. 0.23.
That's not what I got. I got 2,790.234,135.
That's what I got.
Okay,
That's what I got, yeah.
Is that a joint consensus?
Yes.
0.934 to the 7th power times 4,500 and 2,790.23. What would my label be? Cubic inches. So how you can write cubic inches? Cubic means 3 inches with the 3rd power. Okay. So far so good? Questions? Let's look at another one. We've got about 2 more and then we're going to call it good for today. The population of Campbell County, Kentucky has been decreasing at an average rate of about 0.3% per year. In 2000, its population was 88,647. Write an equation to represent the population since 2000. Okay? If this trend continues, predict the population in 2010. So y equals, what's going to be first here?
88,647.
Yep, 88,647. What do I do? 1 minus
0.003.
0.003 to the t power. Okay, so I get y to equal 88,647. What's going to go in parentheses here?
0.997.
0.997 to the t power. Now, we want to find what's the population going to be in 2010. So what are you going to do? 10 for t. So go ahead and calculate that for me. Okay, go ahead and take 88,647, 0.997 to the 10th power.
86,023.21.
86,000. Now, obviously, you get a decimal, right? Can you have a decimal population?
No.
You can't have 0.2 people. So, and a little bit about population with people. If I would get 0.7, you still don't round up. Okay, because you don't have 0.7 of a person. You can't round up and make that 0.7 one person. Okay, so whenever you have people, you always have to go with the whole number value. Okay, so here you go. Here's your assignment, page 434, 4 through 13. A little bit about your assignment. We're going to spend another day on this tomorrow because, yeah, we're probably going to do a worksheet, probably have a short quiz. Okay?
Is this due tomorrow?
Yes.